Hey YouTube family, Namaste. I hope that all of you are very fine. This is Subhradip Nath and I welcome all of you to my channel Bengal Bro Tutorial. Welcome to the second lecture of the chapter Electric Charges and Fields. Just a bit of information before I start this chapter. Students, you all can easily avail the lecture notes from the link given in the description box. So, without any further delay, let's start today's class by briefly discussing about all the topics that we have learned in lecture number 1. We started the previous video by discussing about the elementary particles of matter, which are the electrons and the quarks, because they are the smallest particles of matter that are indivisible. After that, we learned about the concept of charge, which is a property associated with the elementary particles of matter due to which it can experience as well as apply electromagnetic force on each other. And then we learned about the unit of charge in different systems. After that, we learned about the definition of electricity and its type, and then we learned about electrostatics, a branch of physics that deals with the study of charges at rest. After that, a brief historical view about charge was given to you, and then we learned about the types of charges. The two types of charges were named as positive charge and negative charge by an American scientist, Benjamin Franklin. Students, there is one thing that you have to note here is that this naming is purely conventional and has nothing to do with the mathematical meaning. Let me give you an example. Suppose we have two bodies, A and B. One body has a charge of -2 coulomb and the other body has a charge of +2 coulomb. Now in mathematics, obviously -2 is less than +2. But in physics, that will not mean the same. In this case, it means that the two charges have equal magnitude but of opposite nature, due to which they can nullify each other. That's why the two charges were named as positive charge and negative charge, in order to comply with the experimental observation about which we studied in detail in the previous video. And then we learned how does a body becomes charged, which is due to the actual transfer of electrons from one body to the other. And finally, we concluded the last video by discussing about conductors and insulators. Conductors are materials that allow electric charges to flow through them easily. They have a large number of free electrons within the volume, and excess charge given to a conductor distributes itself over the surface of conductor. Also, charges prefer to stay at sharp points, which means if you have a conductor of this shape, say, then here is a sharp point, and if you give some excess charge to this conductor, say positive charge, then the charge density will be higher at this point compared to the other regions. Okay, then we learned about insulators, which are materials which do not allow electric charges to flow through them. They do not have any free electrons, and excess charge given to an insulator resides in that very place where it is given. Alright, so finally we can start today's class with a new topic, which is the method of charging. Now we are going to see how we can charge different bodies by transfer of electrons. Means, what are the different methods by which electrons can be transferred from one body to the other so that we can charge the bodies. The first method is charging by friction. But before we learn about this method, you all have to know about one thing which is known as the work function. Work function. Work function is the minimum energy that is required to eject an electron from the valence shell of an atom. Minimum energy required to eject an electron from the valence shell of an atom. If you want to remove an electron from the valence shell of an atom, then we have to supply a minimum energy, and that minimum energy is called the work function of that body. Okay. Now, this method is used for charging insulating bodies. This method is used for charging insulating bodies or insulators. Okay, so insulators can be charged by this method, which is known as friction. In this method, we have to rub the two bodies. Okay, suppose we have two insulators A and B. So, when we will rub these two bodies, then due to friction between them, heat energy will be generated or heat energy will be created. Now, the body which has lower work function, okay, what will happen? The body which has lower work function will eject the electron faster than the body which has a higher work function. Alright, so after that, what will happen? The electrons from the body with lower work function will transfer to the body with higher work function, and the two bodies will eventually become charged. Understood? Means in this method, suppose we have a body A which has a lower work function, means the energy that is required to eject the electron from its valence shell, will be less compared to the work function of this body. Okay, now when they will be rubbed together, then what will happen? The electrons from this body will get transferred to the electron to this body. Okay, and in this way the two bodies will get charged. This is the method called charging by friction. Now, in this method, both the bodies will acquire, means the two bodies will acquire, charges of equal magnitude but of opposite nature. Means initially both these atoms will have an equal number of protons and electrons, and they will be neutral. Now, when you rub these two bodies, then what? Imagine that this electron is getting transferred to this body. Okay. Now, this body has one electron deficient, and this body has one electron excess. Okay. So, if I ask you what is the charge on this body, you will tell the charge on this body is plus E. And what is the charge on this body? The charge on this body is minus E. So, you all can understand that the two bodies have acquired charges of equal magnitude, but their nature is different. One body will acquire positive charge and the other body will acquire negative charge. Understood? Okay. Now we will learn about the next method of charging, which is charging by conduction. This method is used for charging two conducting bodies or conductors. Means by this method we can charge conductors. This method is used for charging conductors. Okay. Now, in this method, what we have to do is, suppose we have an uncharged body and we want uncharged conductor and we want to charge this conductor. Now, what we have to do is, we have to bring a charged conductor or a charged body in contact with this neutral body. Okay, suppose I bring a rod in contact with this neutral body that is already negatively charged, which means it has got an excess of electrons, and initially this body will have an equal number of positive and negative charge. Now when this rod will be brought in contact with this conductor, this rod will shear some of the excess charge to this body. Okay, so now after the rod is brought in contact with this conductor, some electrons from this rod will shift to this neutral body, and now this neutral body has become charged. Okay, so what you can see is that the neutral body will have the same nature of charge as the one which was used for charging this body. You can see that it is a negatively charged body, and it has been used for charging this body. This neutral body has also become negatively charged. So the neutral body acquires the same nature of charge the neutral body acquires the same nature of charge as the charged body. And another thing that you have to note is that finally both the bodies will now have charges that may be of same magnitude or of different magnitude. Understood? Means the charge distribution will be in such a way that the two bodies may have same magnitude of charge or different magnitude of charge depending on the size of the two bodies. Means if both the bodies have same size, then charges will be distributed equally in the two bodies. But if they have different size, then an unequal distribution of charge will take place. Did you get? Magnitude of charge distributed magnitude of charge distributed or magnitude of charge distributed or magnitude of charge transferred will depend on the size of the two bodies. So this is all about the method of charging by conduction. Now we will look into the third method of charging, which is called charging by induction. Charging by induction. In conduction, what we was doing is the charged body was brought in contact with the neutral body. But in this method, we are going to charge a neutral body without bringing the charged body in contact with it. Let's see how we can do it. Now this method is used for charging conductors as well as materials which are called as dielectrics. This method is used for charging conductors as well as dielectrics. Okay, I will discuss about the concept of dielectrics later, But first let us see how we can charge conductors by the method called induction. For this, say we have a conductor, a neutral conductor, which is isolated, means it is not in contact with any other body, and we place it on an insulating stand. This is an insulating stand. Okay. Now initially this conductor has same number of protons as well as electrons. Now if we bring a charged conductor, say a positively charged conductor, very close to this neutral body, okay, this positive charge will attract some of the electrons in the conductor near its close end. So due to this positive charge, some of the electrons in this neutral body will get attracted towards that end near which the conductor has been brought. Understood? So now you see that both sides of this conductor has two different types of charge. In this region we have an excess of electrons, that means this region is negatively charged, and if you look at this region we will find that this region is positively charged. But the overall charge of this conductor is still neutral. Only a difference in charge has been seen in different regions of this conductor. But overall, since still it is having same number of electrons and protons, that's why overall still it is neutral. Okay. Now this method, okay, in this process in which the charges in a body get separated, okay, when a charged body is brought near it, is called electrostatic induction. This method is called electrostatic induction. Now, if you want to permanently charge this neutral body, then you can do this by two methods. First method is grounding. Remember one thing, student, that ground is called as the source of electron, or it is the ocean of electron. Ground can provide a large number of electrons. So what we have to do is connect this neutral body to the ground by a conducting wire. What will happen? Then the electrons from the ground will travel and occupy these spaces. Alright, then we will cut this contact. Now you see this neutral body has become charged. It has now excess of electron. Now if you remove this charged body, this excess electron will get evenly distributed over the surface of the conductor. So in this way, this is one of the method by which we can charge this conducting body. Now if we bring a negatively charged body near this conductor, then let's see what will happen. See, initially this body will have equal number of protons and electrons. Alright, now when you will bring this negatively charged body near this conducting sphere, then this negative charge will attract some of the positive charge. How it will attract? By repelling electrons that are near this surface. So these electrons will get repelled towards the other end. Okay, so we can see that in this sphere two regions have been created. This region which is near this charged body has positive charge, and the other side is having excess of negative charge, but still the total charge or the net charge in this body is neutral. Now if you want to make this body permanently charged, then what you have to do is connect this body to the ground. Then what will happen? This excess electrons will flow to the ground. Okay, then if these excess electrons flow to the ground, then after that we have to cut this connection. Okay, now you see this body has become positively charged because it has deficient of electrons. And if you remove this charged body, okay, if you take it far away, then this positive charge will get evenly distributed over the surface of the body. This is one method by which we can charge, okay, this conductor by the process called induction. And the second method that we can do is by bringing another neutral body, conducting body, in contact with this sphere. So let's see how we can do that. So initially you have this conducting sphere made to stand on an insulating stand with equal number of positive and negative charges. When you bring a charged body, okay, near this sphere, say negative charge, then it will repel the electrons that are near this end. So they will move to the other side. Okay, now if you bring another conducting sphere in contact with this body, then what will happen? The electrons will be further repelled. Means the electrons from this body will then move to this end, because now this body will total act as a system. Understood? So after that, if we remove this body, okay, if we remove this body or break the contact, then what will happen? This body will become positively charged. Almost similar to grounding only, but in this case we are just bringing this body in contact with another conducting body. Understood? So this is all about the method called charging by induction. Now we will look about dielectrics. What are dielectrics exactly? These are insulators. Okay, insulators that do not have free charges, that do not have free electrons, but they can exert electrostatic force on each other. Means, example of dielectrics are glass, rubber. These are some examples of dielectrics. See, suppose this is a dielectric material. Now, initially this body will have equal number of positive and negative charge. Understood? But when you bring a charged body, okay, near this dielectric, then due to this negative charge, these electrons will be repelled, okay, slightly away. Now again these electrons will repel these electrons, so they will also get slightly displaced. Now these electrons will again displace the neighboring electrons. So now you see, at one side of the conductor, I mean dielectric, we have positive charge, and at the other end we have negative charge. Okay, then again you can make this body permanently charged by the method of grounding or by bringing another conducting body in contact with this body. In this way again you can charge this dielectric. Understood? Means in dielectrics, since it doesn't have free electrons, these electrons, they will not get repelled to the other side. They will just make slight displacement and repel the neighboring electrons. All understood? Okay. Now in this method of induction, okay, you can see very clearly that charges, see, when you will connect this to the ground, the excess electrons will flow and this body will become positively charged. Now, charges of opposite nature develop in the body. You can see charged body that was used is negative, but the dielectric has become positively charged. So charge developed is of opposite nature. One body is positively charged and the other body is negatively charged. And if we talk about magnitude, then in case of conductor, okay, the magnitude of charge acquired by the neutral body will be equal to the magnitude of the body that was used for charging. Means this, what in case of conductor I am talking, the neutral body will acquire same magnitude of charge as the body that was used for charging. But in case of dielectric, the charge acquired will be less than the charge that is present in the body that was used for charging. Understood? So this is a dielectric. In this case, the charge acquired will be slightly less than the charge that is present in this body that is used for charging. I hope that you all have understood very clearly about the three methods of charging. Students, now we are going to discuss about a device which is called as gold leaf electroscope for detecting the presence of charge in a body. Gold leaf electroscope. This is a device that is used for detecting the presence of charge in a body. But remember one thing, this device cannot be used for measuring the magnitude of charge in a body. Only by this device you can understand whether a body has charge or not. It is a device used for detecting the presence of charge in a body. Okay, the device consists of a vertical rod attached to the mouth of a glass vessel. Say you have a glass vessel. What you have to do is attach a vertical rod in the mouth of this glass vessel with a rubber stopper, and at the lower end hang two cold leaves, means strips of cold. Okay, at the lower end attach them, and at the upper end make a knob like structure by coiling this rod. This is just the apparatus. Very simple. In home also you can make this apparatus by using aluminium strips, because you all know that arranging gold strip is not possible. So you can use aluminium foil, right? You can cut there like these strips and make this gold apparatus. I mean this electroscope. Okay. So now how we can detect the presence of charge in a body? By this apparatus. You have to bring the charged body in contact with this upper end, okay, with this knob like thing. Then what will happen? Say this is a charged body that I have brought in contact. Then charges will flow through this rod, because this rod is a conducting rod, and finally it will reach the leaves at the lower end. Since same kind of charge has been acquired by the two leaves, they will repel each other and get diverged. Alright, and the degree of divergence, okay, or the deflecting angle between the two strips will give us an idea about the magnitude of charge in the body. You cannot find the exact magnitude, but you can understand whether it has a greater magnitude or a less magnitude. Means if they diverge to a greater extent, means making a greater angle, then we can understand that the body is having a higher magnitude of charge. And if they do not deflect to that extent, then we can understand that the magnitude of charge in the body is less. This is all about gold leaf electroscope. Finally, we have learned about the different methods of charging and gold leaf electroscope. Now we will look at the different properties of charge. Charge has mainly three properties. First property is additivity of charge. The second property is quantization of charge. And the third property is conservation of charge. These are the three different properties of charge. Now see, charge is a scalar quantity, which means that direction is not associated with charge. Also, charge will obey algebraic law of addition. Now, additivity of charge means that the total charge in a body will be equal to the algebraic sum of all the individual charges in that body. For example, say you have a body in which there are 5 charged particles, Q3, Q4 and Q5, out of which 2 charged particles are negative and 3 charged particles are positive. Now if you have to calculate the total charge in this body, then you have to algebraically add all these individual charges. But one thing you have to keep in mind is that the signs have to be taken into account. You cannot just write the magnitude. You have to add them along with the signs. So the total charge in this body will be Q1 minus or plus of minus Q2 plus Q3 plus of minus Q4 plus Q5. This will be the total charge in the body. This is all the meaning of additivity of charge, which is the first property of charge. Now let us look into the second property of charge, which is quantization of charge. See, in a classroom there are different rows of benches. Now I can order or instruct any student to either sit in the first bench or second bench or third bench. But do you think it will be meaningful if I say the student to sit in 1.5 bench or 2.3 bench? It will not be meaningful, right? Which means that the number of bench, okay, or the row which I am instructing the student to sit cannot assume a continuous value. It can only have positive integral value. I can only say the student to either sit in bench number 1 or bench number 2 or bench number 3. Understood? So similarly, the charge that a body can possess is quantized, which means that it cannot have any continuous value of charge. Because if I ask you to find the total number of charge, if I ask you to find the total charge in this body, then how will you determine? For that you will see the number of excess electrons or the number of electrons that are deficient in this body. If I tell you to calculate the total charge in this body, now you can see that in this body there are two electrons that are in excess. Obviously, these electrons have been transferred from some other body. Now, if I tell you what is the charge in this body, how will you tell me? So, you will say that the charge in this body will be equal to 2 into charge in one electron, which is denoted by E. Okay, since the overall charge of this body will be negative, so we will add a minus sign. In general, if a body has n number of excess electrons or n number of electrons deficient, then the charge in that body will be equal to Ne, where N is representing the number of electrons that has been transferred. Okay. Now obviously you cannot transfer half of electron or 2/3 of electron. That's why this N can have values equal to 0, plus minus 1, plus minus 2, and so on. This is called the quantization of charge, which means that charge can only have values which is an integral multiple of a basic quantum of charge. Basic quantum of charge means it is the charge possessed by an electron or the charge that is possessed by a proton. Okay. Now the question is that what is the cause of quantization of charge? Cause of quantization. Cause of quantization is due to the fact that only integral number of electrons can be transferred from one body to the other during charging, and that is why the total charge in a body is quantized. It can assume only integral values of a basic quantum of charge. Now, why is the charge present in an electron or proton considered the basic unit of charge or the basic quantum of charge? This is because of the fact that this is the smallest possible value of charge that can exist independently, that can be present in a body, and that can be transferred to a body. That is why E is considered as the basic quantum of charge. Understood? In lecture number 1, I told you that protons and neutrons, they are made up of smaller constituents which are called as quarks. A proton is made up of 3 quarks, and so is a neutron. A proton is made up of 2 up quarks and 1 down quark, and a neutron is made up of 1 up quark and 2 down quarks. Up quark and down quark, these are 2 types of quarks. The charge, up quark is denoted by U and down quark is denoted by D. Charge in 1 up quark is equal to 2 by 3e. 2/3 of the charge present in an electron, and a down quark has a charge of -1 by 3e. Okay, so if you want to find the total charge that is present in a proton and neutron, you can easily find. So if you want to find the total total charge that is present in proton, how will you find? 2 into charge in one up quark, which is equal to 2 by 3e, plus 1 into charge that is present in one down quark, which is equal to minus 1 by 3e. So 4 by 3e minus 1 by 3e, which is equal to 3 by 3e, which is equal to e. Understood why the charge in a proton is equal to the charge in an electron. Now if you want to calculate the charge in a neutron, you can easily do that. So charge in a neutron can be calculated in this way: 1 into charge in one up quark, which is equal to 2 by 3e, plus 2 into charge in one down quark, which is equal to minus 1 by 3e. It is 2 by 3e minus 2 by 3e, which is equal to 0. And that's why neutrons are neutral particles. Now you may have a question that why are quarks, why is the charge that is present in quark not considered as the basic unit or basic quantum of charge? This is because so far isolated quarks have not been discovered. Understood? Till now scientists have not found the presence of charge, presence of isolated quarks. That's why quarks cannot be considered as a basic quantum of charge. Now we will address one question, that under what condition can the quantization of charge be ignored? When can we ignore quantization of charge? We can ignore this property when we are dealing with macroscopic charges. Okay, in most of the practical situations, the value of n, q equals to ne, the value of n is so large compared to this magnitude of charge present in one electron. For example, if I switch on a 60 watt bulb, then about 2 into 10 to the power 18 electrons will flow through the filament of the bulb per second. Can you imagine this number? 2 into 10 to the power 18 electrons are flowing per second through the filament. And so that's why the granular nature of charge cannot be detected, and we will not see that the bulbs are getting on and off, because the charges are going to flow continuously. That's why while dealing with macroscopic situation, the quantization of charge can be ignored. But the quantization of charge has to be very carefully taken into account when we are dealing at the microscopic level. Finally, we are going to look at the third property of charge, which is called as the conservation of charge. This is very simple and is similar to the conservation of energy that we have learned in class 11. According to this property, the total charge of an isolated system is conserved, which means that charge can neither be created nor be destroyed but can be transferred from one body to the other. See, when the two bodies are neutral, does it mean that there is no charge present in the body? No, right? It means that there are charges but they are nullifying each other. So when we are charging the two bodies, it is not that we are creating charge. Only there is transfer of charge that is taking from one body to the other. Okay, which causes a net charge in both the bodies. So the total charge of the two bodies will remain same even after the two bodies are charged. This is the meaning of the third property of charge, which is called as the conservation of charge. I just missed out one important point, okay, in the second property, quantization of charge, that this property can be experimentally verified by Millikan's oil drop experiment. Okay, from that experiment you can experimentally verify the second property, which is the quantization of charge. Now let us look at the effect of speed on the mass and charge of a body. According to Einstein's special theory of relativity, energy and mass are interconvertible, and this conversion is given by the relation E is equal to mc square, where E is the energy equivalent to mass m. Here m is the relative mass, means mass can be converted into energy and energy can be converted into mass according to Einstein's special theory of relativity. If you want to suppose you are measuring the mass of a body to be equal to 3 kg, okay, mass of a moving body. Now if you want to calculate the energy equivalent to this mass, then you have to multiply 3 with speed of light, square of speed of light, and then write the final answer in joule. You will get the energy equivalent to this mass. Here m is the relative mass of a body, okay, means it is the mass of a body that is moving with velocity v. Mass of a body moving with velocity v. Now how can you calculate this relative mass? You can calculate this relative mass using the formula m is equal to m naught by under root 1 minus v square by c square. Now again you have another term which is m naught. Here m naught means the rest mass of the body. V is the velocity of the body and c is the speed of light. Now, what is this rest mass? Rest mass means it is the mass of a body measured in a frame of reference which is at rest. For example, I am standing here and I can see that another person is also standing beside me, which is at rest. That means according to my frame of reference, the mass, that body is at rest, the other person is at rest. So the mass which will be calculated by me, that is going to be the rest mass of that person. Now if another person in space is observing the person who is standing beside me, according to that person, that the person who is standing beside me is moving, understood? So the mass which will be calculated by his frame of reference will not be considered as relative mass, understood? Means mass of a body measured in a frame of reference which is at rest, that is called as the rest mass of a body. Okay, and what is the relative mass? Relative mass means it is the mass of a body which is found by this formula. Now see one thing, any body cannot exceed, the speed of any body cannot exceed the speed of light. So V will always be less than C. So from this we can say V by C will always be less than 1 and V by C whole square will also be less than 1 because 1 square is equal to 1. So this value is less than 1. So overall means if you are subtracting a value which is less than 1 from 1, you will get a like fraction. Like fraction means any value that is less than 1, right? C1 like fraction means 2 by 3 where the numerator is smaller than the denominator. So in this case you will always get a like fraction. Fraction means the final answer will be of something of this kind which will be less than 1. Now when you are going to divide any number with like fraction, the final answer is going to be greater than the number which you are dividing. See, for example, m0 is 3. Okay, now if I divide 3 with a like fraction, say 2 by 3, then the final answer is going to come 3 into 3 by 2, which is equal to 9 by 2, which is equal to 4 point something. So this number is greater than the number which I am dividing. So finally the relative mass of the body, the value of relative mass of the body will always be greater than its rest mass, which means that the mass of a moving body is greater than its rest mass. And finally we can conclude that mass is relative and is observer dependent. Okay, the mass of a body depends upon the frame of reference from which it is measured. But charge is invariant, means charge does not depend on the frame of reference from which it is measured. Whether the charged body is moving or whether the charged body is at rest, the magnitude of charge measured in both the frame of reference will be same. Understood? So finally we can say that mass is relative and changes with speed, but charge is invariant, means it does not depend on the frame of reference or it does not depend on whether it is moving with some speed or not. Finally, we are going to look at the difference between charge and mass. Okay, what are the difference between mass and charge? Can you now differentiate between mass and charge? Let's see them one by one. First point, mass is always positive. Always positive, but charge present in a body can either be positive or negative or zero. Charge can be positive, negative or zero. Second point, mass of a body changes with speed. Charge of a body does not change with speed. We have just seen this thing. Third point, mass is not quantized. Which means that mass of a body can take any value. Okay, a body can have mass of any value. The value is continuous, but charge is quantized. charge is quantized. Third point, mass is not conserved, which we have seen in the mass energy equivalence relation. Mass can be converted into energy, energy can be converted into mass, but charge is conserved. The total charge in this universe is constant and does not change with time. This is the fourth point. Charge is conserved. The gravitational force due to masses is always attractive in nature, right? Gravitational force is always attractive, but the electrostatic force due to charge may be attractive or repulsive. This is another point of difference. All right, now we will look at one very important point. See, a body having mass may or may not have charge, but in this world you cannot find a body or anything that has charge but no mass, which means that mass is always associated with charge, but a body having mass may or may not have charge. Okay, a body having mass can be neutral or can have a charge, but a charged body will always have mass. This is the last point of difference. So mass, a body having mass may or may not have a charge, but a charged body is always associated with some mass. So these are some of the difference between the two properties of matter. One is mass and the other is charge. Finally, we are going to conclude this chapter with a very important concept. See students, two bodies can get attracted towards each other, maybe due to gravitational force, okay, or they may get attracted towards each other maybe due to the presence of charge. Alright, so you cannot determine if the two bodies are getting attracted towards each other. You cannot say whether they are getting attracted because of gravitational force or because the two bodies are charged. But repulsion is the surety check for charge. Means if two bodies are repelling from each other or if they are getting repelled away, that means you are 100% sure that the two bodies are charged. This is the important conclusion, that repulsion is the surety check for charge. Thank you for watching this video lecture till the end. Alright, so we are ending this class. Till then, take care of yourself, study well and prepare for your exam. And if you have any doubt, then you know what to do. Use the comment section. Alright, goodbye.